Hello my students, this is the 7th lecture during the COVID-19 holidays. We ask Allah to overcome this epidemic. Say Ameen. The chapter 8 contains uniform and exponential distribution. We will study only the uniform distribution, and we will cancel exponential distribution. So we cancelled before the hypergeometric distribution, and now we cancel exponential distribution. So one discrete distribution was cancelled before, and now one continuous distribution is cancelled now. Okay, so what is the meaning of uniform probability distribution? Okay, first I would like to say that this uniform distribution looks like a rectangle, okay? So it has a base or a width and a height. The height of this rectangle represents the probability density function, and the base of the rectangle represent an interval between 2 points, say A and B. And as you know, the area included in this rectangle equal 1. So the height of the rectangle will be 1 over B minus A, 1 over B minus A, as you will see later. Okay, now assume that the random variable x represents the flight time of an airplane traveling from Cairo to Aswan. Okay, suppose that the flight time can be any value in the interval from 60 to 80 minutes. Okay, 60 minutes to, this is the interval between 60 minutes and 80 minutes. Okay, so this is the time of traveling from Cairo to Aswan. And also assume that the probability of the flight time during any 1 minute interval is the same as the probability of a flight time during any other 1 minute interval included in the whole traveling period of time from 60 to 80 minutes. Okay, so every minute it looks like another minute. Okay, I mean the speed is the same for every minute. You see, in this case the random variable x has a uniform probability distribution. The probability density is a function for the flight time. A random variable x is denoted as f of x equal b of x equal 5% for x between 60 and 80. Okay, this is the case. So 1 over the difference between 60 and 80 equal 20. 1 over 20 means 5%, and bx equals 0 otherwise. Okay, so outside, whether less than 60 or greater than 80, the probability density function equals 0. Okay, so this only the range of the distribution, the range between 60 and 80. Okay, there is no any other interval larger than 80 or less than 60. The probability density function equals 0 otherwise. Uniform probability density function. The domain of a uniform random variable x contains all values with some interval such as x equal to or greater than a and less than or equal to b. Okay, so x is between a and b, or from a to b. So random variable x defined over such interval is uniformly distributed if its probability density function is given by the following formula. This is the formula. This is the height of the rectangle. This is the probability density function. Okay, so the probability density function equal the height of the rectangle, and the height equal 1 divided b minus a, the difference or the length of the interval or the base of the rectangle. Okay, b minus a equals the base or the width of the rectangle, and 1 over b minus a is the height or the probability density function. Okay, and equals 0 elsewhere. Okay, so if x is less than a or greater than b, the probability density function or the height equals 0. Look at this figure. This is the height. The height at any point is constant. Okay, the height of the rectangle is constant, and this is the base. This is the base or the width of the distribution, the interval between a and b. So because the area of the rectangle equal 1, so the height equal 1 divided b minus a. 1, this area, divided b minus a, the base or the width. Okay, so area as a measure of probability. Area as a measure of probability. The area under the graph of the uniform probability distribution is rectangular, and the area of the rectangle is simply computed by multiplying its width, its base, by its height. Okay, so the width or the base is the same. The height is the probability density function, as we explained before, and the width of any interval is the difference between the two limits of this interval. Okay, so during any interval between a and b, the probability density function hold true, equal 1 divided this interval. Okay, so the formula of finding the probability that x takes a value between a higher value d, for example, and a lower value c, for example, will be as follows. Look at this. The probability that x is between c and d, where c and d is included in the rectangle. So c must be equal to or larger than a, and the D must be equal to or smaller than B. Okay, so this probability equal D minus C, the interval between D and C, divided B minus A. Okay, or the height multiplied by the base of this interval, so the base of the interval is D minus C, where D is larger than C, and the height of the rectangle is 1 divided B minus A, right? Okay, so you can get any probability by multiplying the height by the interval, or the difference between the two limits of the interval, right? The following figure displays the area under the uniform distribution which represents this probability. Look at this. This is the height, as we explained before. This is the base of the rectangle of the distribution, and this is the interval where X is between C and D. Okay, this area represents this probability. The probability that X is between C and D equal the base multiplied by the height. The height is the same for any area, for any interval, for any probability. Okay, this height equal 1 over B minus A. Okay, but the interval with the base equal D minus C. This is the base of the small rectangle, this one. Okay, so the area under this rectangle, the smaller rectangle, equal D minus C divided B minus A, or 1 divided B minus A, then multiplied by D minus C. Okay, the mean and the standard deviation of uniform distribution. As you see, the mean of the distribution, look here, the mean of the distribution is the intermediate point here, intermediate here. So this mean equal A plus B divided 2, A plus B divided 2. This is the mean of the distribution. Okay, the intermediate point between A and B. Okay, so the mean denoted by mu equal A plus B divided 2, and sigma equal the square root of B minus A. B minus A means the base of the rectangle squared divided 12. Okay, this is a formula, this is the rule. Note that the expected value means the mean of X is the midpoint of the domain of X, midpoint of the domain between A and B, because of the symmetrical shape of the probability density function. symmetrical shape of X. Also, the total area of the rectangle under the uniform density function f of x equals 1. اوكي equal 1. مساحة المستطيل بتساوي 1. يونيف بي دي اف دي الدالة بتاعت حساب دالة كثافة الاحتمال او ارتفاع التوزيع المنتظم. So UNIF PDF continuous uniform probability density function. Syntax y equal UNIF PDF x and a and b. A and b are the limitation of the distribution. This is the lower value and this is the higher value. B is the higher value and A is the lower value. Description. Unique PDF X, A and B computes the continuous uniform PDF at each of the values in X using the corresponding lower in the point. Lower is B, lower is A in the point minimum, A, and upper in the point which is B maximum. X and the A and the B can be vectors, matrices, or multi-dimensional arrays that all have the same size. Okay, a scalar input is expanded to a constant array with the same dimensions as the other inputs. We will not deal with the multi-dimensional or matrices, just we will use vectors, okay, or single values of X. The parameters in B must be greater than those in A. Okay, so A and B are the parameters of the uniform distribution. UNIF CDF, the cumulative distribution function, continuous uniform cumulative distribution function. Okay, so P equal UNIF CDF X, A and B, and the second is X, A, B, and the upper is the complement probability, Okay, so if we have 2 points included between A and B, and we need to compute the probability outside these 2 points, we can use upper or 1 minus, okay? So upper means the complement probability. UNIF CDF returns the uniform CDF at each value in X using the corresponding lower endpoint minimum, A, and upper endpoint maximum, which is B. X, A, and B can be vectors, matrices, or multidimensional arrays that all have the same size. As we said before, a scalar input is expanded to a constant matrix with the same dimensions as the other inputs. And also CDF, you can use upper to get the complement probability. Okay, You need stat to get the mean and the variance. Looks like any function for any other distribution. Stat. The word stat means the mean and the variance. So univ stat is a function to get the mean and variance. Okay. Univ stat A and B, the parameters of the distribution. Okay. M and V, the arguments, equal univ stat A and B, returns the mean and the variance for the continuous uniform distribution using the corresponding lower endpoint minimum, which is A, and upper endpoint maximum, which is B. Vector or matrix input for A and B must have the same size, which is also the size of M and V. A scalar input for A or B is expanded to a constant matrix with the same dimensions as the other input. Example: consider the random variable x represents the training time of a student who wants to learn descriptive statistics using MATLAB. هنا x متغير عشوائي بيمثل زمن تدريب الطالب اللي عايز يتعلم إحصاء بالماتلاب. Using MATLAB. Assume that the training time can be any time in the interval from 20 to 30 hours. التدريب ده بيحتاج ما بين 20 إلى 30 ساعة. So this is the limitation of the uniform distribution. A equal 20 and B equal 30. And the height equal 1 divided 10, the difference between 30 and 20, right? And the x is uniformly distribution over this interval. This interval means between 20 and 30. Find number 1 or number A, the height or the probability density function of the distribution. As we said, the height will be 1 divided 30 minus 20, so 1 over 10. Okay, the mean and the standard deviation of the distribution. Okay, the mean equal A plus B divided 2, which is 20 plus 30 equal 50 divided 10 equal 25, and the standard deviation equals the square root of B minus A squared divided 12. The probability that the training time is at least 25 hours. At least means 25 hours or more. To what? More until reach 30, because 30 is the higher value of the distribution. Okay, so when I say at least 25, we mean the difference between 30 and 25, okay, which equal 5. So the base here equal 5 and the probability equal 1 divided 5, right? The probability that the training time is between 22 and 20 hours. This is the limitation. assuming that 22 is C and 25 is D. So D minus C divided B minus A. D 25 minus 22 divided 30 minus 20. Okay, this is the probability computing by hand. The probability that the training time is at most 24 hours. At most means the maximum is 24. So this means that 24 or less, 24 or less, or smaller. Okay, so the smallest value is A, which is 20. Okay, so the difference between 24 and 20 is the base of the area according to this probability. Solution by hand. The height of the distribution equal the total area under the uniform distribution, or 1. You know that the total area equal 1 divided by the base or the width of the rectangle as follows. This is the height. So the height or the probability density function, or P of x equal 1 divided B minus A, 1 divided 20 minus 20 equal 1 over 10 equal 0.1. The mean equal A plus B divided 2 equal 20 plus 30 divided 2 equal 25. This is the mean of the distribution. And the standard deviation equals the square root of B minus A squared divided 12. 30 minus 20 squared divided 12. So the square root of 100 divided 12, okay, equal 2.9. Number C, the probability that x equal to or greater than 25 means that x is between 25 and 30, as I explained before. Okay, so here D equal 30 and the C equal 25, then D minus C divided B minus A equal 30 minus 25 divided 30 minus 20, okay, equal 5 divided 10 means 1/2, right? Okay, the probability that x is between 22 and 25 equal 25 minus 22 divided 30 minus 20. So this equal 3 over 10 equal 0.3. By MATLAB, using the function UNIF PDF and UNIF CDF and UNIF stat, we have, okay, UNIF PDF to get any probability, UNIF CDF to get any cumulative probability, okay, and UNIF stat to get the mu or the mean and the variance or the standard deviation. Okay, so here the lower value is 20, the higher value is 30, and the x take any value between 20 and 30, any value, okay, any value. So P of A, the probability, the height equal 1 divided B minus A equal 0.1, as we did by hand. Or you can use unique PDF X and A and B, where X equal any value between A and B. For example, 21 or 22 or 25 or 29. Okay. So this probability equal 0.1. Mu and V or M and V equal unique stat to get the mean and the variance or the standard deviation. A and B, the parameters of the uniform distribution. So M equal 25. So the mean or the expected value equal 25, and the variance equal 8.3. So sigma or S, the standard deviation, equal square root of variance equal 2.88 or 2.9. Okay. So we finished the uniform distribution now. As we said, we will cancel the exponential probability distribution. Okay. Best wishes to you, and I will record later the type of the exam, but I believe that most of the exam, the final exam I mean, will be MPQ. MSQ means multiple choice questions. Multiple choice question. And I know that you love it. You like MCQ. Okay? That's it. Best wishes to all of you. Thanks a lot.